Here we'll discuss on the Mohr circle. Mohr circle. This Mohr circle is very important to solve the problem related to the principal stresses, that is a normal stress, principal stress or maximum shear stress. We can easily find out with the help of this Mohr circle. This Mohr circle had been developed by this Mohr. Mohr have this the Mohr had developed this graphical method, this graphical method to determine normal stresses, to determine normal stresses, principal stresses and shear stresses. This is the two-dimensional, the geometrical representations, and with the help of this Mohr circle we can determine all the mentioned the stresses here. So this Mohr circle has some advantages over the analytical method, that in the help or with this help of with the use of Mohr circle, all the mentioned stresses we can find out in one circle itself, rather than in an analytical method. We have to use a number of the times the formula to determine the angle or oblique plane on any component, such as if you see here, this is the component here. If the angle theta is there, maybe 30 degree, 40 degree, whatever. So for this particular theta we have to use one formula related to the principal stress, shear stress and normal stress. If another theta is given in same component, then for this particular theta again we have to use repeatedly the formulas to find out the value of this theta 1. Similarly the theta 2 if it is given, so every time repeatedly we have to use the formula to find out the theta 1 and theta 2 value. But in the Mohr circle, all the value itself can be found out in only one circle. So this is the advantage of the Mohr circle over the analytical method. So how to solve how to use this Mohr circle to solve the problem related to the normal stresses, principal stresses, shear stresses and the oblique plane if it is given in any component. So for that, the simple steps are there to solve to use this Mohr circle to solve the all mentioned problems. For this we have to know first the coordinate system. This is the coordinate system. We know that this is the positive x, positive y, and this is the negative x, positive y. This is the negative, and this is the positive and negative. X is a positive, y is a negative. This is the coordinate system. And this x-axis, always we have to remember, this x-axis in the Mohr circle represent the normal stress. This represent the normal stress. This x-axis always represent normal stress in the Mohr circle. So this side, this is the positive one, the positive, and this is the negative normal stress. And the vertical plane, this coordinate system, the vertical direction shows the shear stress. is the positive and this is the negative shear stress. So this is the coordinate system where we represent the normal stress and the shear stress in this coordinate system to construct a Mohr circle. So Mohr circle always construct in these two axes, where x-axis denoted the normal stress and y-axis is denoted shear stress. This will be our reference or origin to construct the Mohr circle. Now to construct the Mohr circle, let we take one example of any component. Here this is the small element of any component, where this is the shear stress, this is the shear stress, and the normal stress direction is like this in the plane sigma y, sigma x, sigma x. This is the tau, tau, tau and tau. Now in the same question, any type of question supposed to given in the question paper, whether the direction is anything else, just we have to find out first the coordinate of the plane. Suppose this is the x plane and this is the y plane. So in x plane, if you see, sigma x is positive, so this is the sigma x, but tau, if you see here, the sense of tau to rotate this element is anti-clockwise, so we take minus tau. So this is the coordinate of the x-axis or x plane. Now in a y plane, if you see, this sigma y is positive because it's a tensile in nature, and if you see the shear stress which rotate this element clockwise, so here this will be positive. So now first we find out this coordinate of this element. This is our first point or first thing to construct the Mohr circle. Now if we find out this coordinate in this given system, now let me draw. So this x plane, if you see, sigma x, and we assume always the sigma x is greater than sigma y, then the sigma x is positive, so this is the positive coordinate system. This side, let we take this sigma x. So how we plot this sigma x in this Mohr circle? For that, what we do, the stress, whatever the stress is given of this sigma x or sigma y or tau, we convert this stress first. We convert this stress to length. Suppose we have the 1 megapascal, we take as a 1 mm in a scale. So length we have to take as a scale. This is our scale. So stress is converted into a length. So if it is 1 megapascal, we take 1 mm. So whatever the megapascal will be there, says 100 megapascal, it can be 100 mm or 10 centimeter. This scale we can take and plot the Mohr circle. Okay, so first of all, the very important thing is that suppose this is our plane. I am denoting this plane AB and this plane is AC. This X plane is a AB plane and this vertical plane Y plane is a AC plane. The first consideration point to construct the Mohr circle is whatever the plane is there, that plane will be the point in the circumference of the Mohr circle. So this AB will be the point of the circumference, point on the circumference of the Mohr circle. This AC also will be the point on the circumference of the Mohr circle. This is the first point that you have to consider. I'll explain one by one. So suppose this is the sigma x. I'll write the coordinate system for the sigma x minus tau. So sigma x, suppose sigma x is greater than, so I just denote the sigma x will be here. If it is 10 megapascal, so the 10 mm scale will take and make this point, which is the sigma 1 from here. This is the sigma x from the reference. This is the our origin. From the origin we have to take any length, any scale we have to take from the origin. Now the second one, so sigma x minus tau, this is the minus tau. So tau, whatever the stress will be there in a tau can be denoted here, because the tau is negative. So this will be our sigma x minus tau. This is the coordinate system, and here this is the tau. This length is complete. Tau is there, this vertical length. This x-axis is a sigma x. So whatever the stress will be there, they can be converted into the length first, and this draw the scale. Through this scale we make a point on that. Similarly, if you see the sigma y, which is positive, but the sigma y is less than the sigma x, so the point will be somewhere else lesser than the sigma x. So it would be here, and this will be the sigma y. Now this will be the sigma y from the origin. What about the tau? Tau will be here, but it is a positive, so it will go the positive here. Magnitude of this tau will be same. So whether it is an x plane or y plane, the value of tau will be same magnitude. So whatever the length will be here, same length will be here. So this will be our sigma y and tau. So this is the another plane. This is called a plane. Sigma y or tau is nothing but a plane. This point is a plane, that is our AC plane. This will be our AC plane. So, and this will be our AB here. AB plane will be here. This will be our AB plane. Now what we do, the next step, we join these 2 points, this plane from the center here. We join this 2 point. This is the plane, this is the plane, AC plane, AB plane, X plane, Y plane. The coordinate of the X plane is this, and coordinate of the AC Y plane is this. Now what we do, we just take the diameter of this is the diameter, and we take the diameter or the radius. This I give center point C, and from C to this AC I take as a radius, and I can draw a circle, and I can draw the circle which touches this 2 point and will be like this. So this is called the Mohr circle. So the very important things are, this is the Mohr circle, and this is the circumference of the Mohr circle, and what we have talked that each plane will be the point on a Mohr circle. So here we can see that the plane is a point on the circumference of the Mohr circle. This is the X plane, AB plane, this is the Y plane, AC plane. So this is the point in a Mohr circle. This is one important consideration, and from this reference to this is called sigma x. This is the sigma x, and from here to this is the sigma y. This is the sigma y, and here to here this is tau. From here to here this is tau. So likewise we can solve the problem by using this Mohr circle. Now suppose in a question, if it is given any angle theta from the vertical. Now where will be the position of theta in a Mohr circle. So one important point is that this theta which is in the element will be double in the reference plane in the Mohr circle. So whatever the theta value will be there in the element will be double in the Mohr circle, means will show the 2 theta in the Mohr circle. This is the another important consideration. But where we have to plot this theta. So to plot this theta, what we have to do, we have to take first the reference plane. So sigma x is greater, that's why this will be the reference plane for us, and from this reference plane we draw this theta. So suppose the sense of theta from this vertical plane is clockwise. Now here this is our plane AB, this is our plane. So this is our plane AB, then from A to C this will be our reference line. This will be our reference line in the Mohr circle, and from this reference line we have to take the direction of theta. This is very important. Now we know this is our reference plane, so this is the reference line, and from this we have to make the theta angle which is clockwise from this reference plane. So this is the reference line, and from this is the clockwise direction, means the theta will be here, that we have to make through this protractor. We have to use the protractor and we have to make this theta angle which will be 2 theta from this reference plane, and here in this direction we have to make this clockwise direction. So clockwise direction we have to take the protractor and we have to make this angle 2 theta. From here to we have to rotate this side. So theta will be represented here in the Mohr circle as a 2 theta. So this will be another plane. So whatever the plane will be there, A D, suppose it would be plane, so this would be A D, and from here we just take the straight line here which will be our tau. So this will be our tau. So this maximum shear stress we can find out on this oblique plane by drawing this oblique plane with the help of this reference line using protractor making 2 theta, and from this plane, this is the another plane, this is oblique plane, and from this oblique plane if we draw this perpendicular line on this axis, so this will be denoted a tau. So this is the all about the Mohr circle, and once we solve the problem related to the Mohr circle, it will be very clear to you how you have to use this Mohr circle and solve the problem to find out the principal stresses, normal stresses, and the maximum shear stresses. Thank you.